All right, so in this video, we're going to talk about half angle formulas for sine and cosine. So first, let's talk about where they come from. So they actually derive from the double angle formulas. So first, we're going to write the cosine of 2a formula, but in terms of sine, right? Because there are three formulas for the cosine of 2a, cosine squared minus sine squared, all right? That's one of them. Right, it's not in terms of sine, it's in terms of sine and cosine. But remember, if that's a I. Remember that cosine squared is equal to 1 minus sine squared, because sine squared plus cosine squared is equal to 1. All right, so if we take cosine squared and replace it with 1 minus sine squared, we get 1 minus sine squared and then minus sine squared. And then that gives us the formula for the cosine of 2a in terms of sine, which is 1 minus 2 times the sine squared of theta. All right, so here's one of the formulas, double angle formulas for cosine. Here's the other double angle formula for cosine. And then the third one would be 2 times cosine squared minus 1. All right, so we're going to use the middle one. We're going to use 1 minus 2 sine squared. All right. Oops, I want that frozen on the screen. Okay, so we got 1 minus 2 times the sine squared of a, right? If that's equal to the cosine of 2a. So therefore, the sine of theta, all right, so instead of theta, we'll keep it consistent. It should be a. So we'll do the sine of a, would be, well, now we got to solve. So I'm going to add 2 sine squared to the other side of the equation and subtract the cosine of 2a. All right, so I'm taking this equation here and I'm isolating sine by adding 2 sine squared a and subtracting cosine of 2a. All right, then I'm going to divide by 2. Okay, so I get the sine squared of a is equal to 1 minus cosine of 2a, which means if I take the square root, I get the sine of a, all right, is equal to this, 1 minus cosine of 2a over 2. So now I did take the square root, so I should add the plus or minus. So plus or minus 1 minus the cosine of 2a over 2. I think that was it, right? So sine squared, yeah, 2 sine squared, that makes sense. All right, so the half angle formula means it's the sine of a over 2, half of a. So like this sine of half of an angle that you can evaluate without the calculator. So if we replace theta, all right, so this would be theta. If we replace theta, so it's kind of confusing there. Theta and a mean the same thing. But if we replace the input, the angle, with a over 2, so we plug in an a over 2 here. So now this becomes a over 2. Then our formula is plus or minus the square root of 1 minus the cosine of just a, because here we get 2a over 2. All right, that's just a, all over 2. So that is the half angle formula for sine, and I'll show you how to use it. And again, it's when you need to take the sine of an angle that's half of one that you could evaluate without a calculator. So like the sine of 15, you can use the half angle formula. Like 210, right? We could do the sine of 210. If we wanted to do the sine of half of 210, which is 105, we would use the half angle formula. And I'll show you how to work that. But for now, this is the formula. All right, now the plus or minus, it's not always going to be a plus or minus. You have to figure out what quadrant the angle is in, and then you can determine whether it's going to be positive or negative. So you have to know what quadrant the angle is in to figure it out, whether it's positive or negative. And I'll show you how to do that right now. So that's the first formula. All right, and we'll write these down at the end if you forgot. I told you we'll figure out how to determine the angles. We'll do that in the next slide. But now let's do the half angle formula for cosine. So so now the double angle formula for cosine of 2a was, I believe it was 2 cosine squared of a minus 1. I'm just going to double check that right now in my head. So cosine squared minus sine squared. Yeah, that makes sense. Okay, so that's good. So now, therefore, the cosine of theta, all right, so, or the cosine of a, now we got to isolate a. So I'm going to add 1 to both sides, and I get cosine of 2a plus 1 is equal to 2 cosine squared of a. Then I'm going to divide by 2, all right? And then I'm going to take the square root, and I get plus or minus, so the cosine of a, right here, without that, because we took the square root, is equal to plus or minus the square root of the cosine of 2a plus 1, all right? So I can erase this. Now, if I replace the input with a over 2, like it says in the bottom step, thus giving us the half angle formula, okay, this will cancel out here. And we get the cosine of a over 2 is equal to plus or minus the square root of the cosine of a plus 1 all over 2. All right, so if you were trying to evaluate the cosine of an angle that's half of one, we could do without a calculator, like 22.5, right? That's half of 45. Then you would let a be 45. So now that's the cosine of 22.5. But then you would plug 45 in right there, and that's something that you can evaluate without a calculator. And then you have to determine what quadrant the angle's in. So 22.5 is in quadrant 1. So this will ultimately be positive. And make sure that you put the over 2 is under the radical. All right, and I'll show you more specifically how to use this formula, but it's pretty straightforward once you see it. All right, so the 2 is under radical. Yes, this is not rationalized, so you could rationalize it when you're doing the problem. But in the formula, it's not rationalized. So now how do we determine, so the formulas both have plus or minus in them. So how do we determine whether it's positive or negative? I'm gonna show you that right now. First, no problem. If you're late, not a big deal. So, right, so let's say you're given an angle in quadrant 1. So that would be something like, so in quadrant 1, A would be in between 90 and 0, right? And let's say it includes those two. So that means A over 2, so half of that angle, would be in between 0 and 45. So, which means that half of that angle would belong into quadrant 1. So that means the sine of A over 2, as long as A was in quadrant 1, then A over 2 will be in quadrant 1, right, is going to be positive, and cosine will be positive as well. All right. Now let's say A, so double the angle that you're taking the sine or cosine of, because we're doing the half angle formula. All right, so let's say that A is in quadrant 2. All right, so that means A is in between 90 and 180. Okay, well then if we do the half angle formula, so we do A over 2, that means that A over 2 is going to be in between 45 and 90. So if A is in quadrant 2, half of A has to be in quadrant 1, because half of 90 and 180 is between 45 and 90, which is quadrant 1. So A over 2 would still be in quadrant 1, which makes sine positive and cosine still positive, because all trig functions are positive of angles in quadrant 1. All right, that's what this ASTC thing shows you. All right, in quadrant 1, all trig functions are positive. In quadrant 2, if you have an angle, the sine of that angle is positive, cosine and tan are negative, right? Tan is positive in quadrant 3, cosine is positive in quadrant 4. The other trig functions are negative. And the reciprocals go together. So like if sine is positive in quadrant 2, and so is cosecant. All right, but like secant, cotangent, tangent, cosine would all be negative. All right, so now let's do the same thing for quadrant 3. So in quadrant 3, A would be in between 180 and 270. So A over 2 would be in between 90 and 135, because that's half of 180 and half of 270. All right, so that's quadrant 2, 90 and 135. All right, so in quadrant 2, sine is positive and cosine is negative. So if the angle, the original angle, not the half of the angle, so the one that you're using to evaluate in the formula is in quadrant 3, then if it's the sine of half that angle, it's going to be positive. If it's the cosine of half that angle, it's going to be negative. And again, I'll show you how this works, but this is the gist of it. All right, and then this last one. And again, this is for like, if you might be thinking, well, what if we know that A is, 47 degrees, and obviously the cosine of half of that is, half of 47 is 23.5. Then half of that, like the sine of that, will be positive because it's quadrant 1. Well, this is for when you don't know the angle. This is for like when you're drawing a picture. This is how you think about it. All right. So last one, quadrant 4 is in between 270 and 360. So half of the angle would be in between 135 and 180, which is quadrant 2. So that means sine is still positive, cosine is negative. All right. Cool. So let's apply this formula real quick. All right, so the cosine of 105. Now, you could do this with the sum formula, right? You could do the cosine of 60 plus 45, and you get one answer, right? Or you could do this using the half angle formula, and you'll get another answer. But those two answers will be the same thing, because the cosine of 105 should also always equal the cosine of 105. They might look a little different because of the way they simplify, but if you simplify them all completely or put them as decimals, you'll see that it's the same thing. All right, so again, you could do this with the sum and difference formula, but we're going to use the half angle formula. All right, oops, I gotta let someone in. There's someone left, I'm not sure. I heard it beep. All right, so cosine of 105. So for the cosine of 105, we need the half angle formula. So let's pull them up. All right, if you haven't done so yet, I'll give you a chance. You should write these down. Oops, that's the double angle formula. Not that. I should put these in the notes. That's my bad. So let me give you a second and just let's all make sure we have these in our notes. So I'll pause the recording and you can write this down. Now we didn't see how tangent was derived, but if we just divided the sine of pi over 2 over the cosine of pi over 2 and then simplified, then we would get these half angle formulas for tangent. So you can either do sine and cosine and divide them yourself, or you can just use this formula. So you can write that down. All right, so I'm just gonna give everyone 30 seconds to write that down. Very good. 200. So if we're doing the cosine of 105, you want to use 210. So we got, oops, technical difficulties. We got the cosine of 210 over 2. All right, so 210 for 2 reasons. Now, if I said just evaluate the cosine of 105 without a calculator, like we said, you could use the sum formula. Or if you notice that it's half of an angle that we could evaluate, then that's when you know you use the half angle formula. That's why it's called that. So now in the formula, it's the cosine of A over 2, because in this case, A over 2 is equal to 105. So A is 210. So we're going to do the square plus or minus. We'll come back to that part in a second. Plus or minus 1 plus the cosine of 210 all over 2. All right, now we know, since it's the cosine of 105, all right, in this case, we know the angle specifically, so there's not too much thought that goes into it. We know that it's going to be positive because, sorry, check that, negative, because it's the cosine of an angle in quadrant 2. And we know that cosine of angle in quadrant 2 is going to always be negative, all right, because cosine is x over r, and x is negative, r is positive. All right, so now we got to evaluate this part inside the radical. So we get 1 plus the cosine of 210, all right, which is what? Someone want to tell me what that is?
Radical 3 over 2.
Very good. Negative though, because it's in the 210 is in quadrant 3, but very good. Negative radical 3 over 2. That part's good. All right, because 210 has a reference angle of 30, and the cosine of 30 is root 3 over 2. All right, so now we just got to clean this up a little bit. So 1 minus radical 3 over 2 over 2. So we have some sort of like complex fraction here. So to get rid of that, we could multiply this by a form of 1. So it's really like root 2 over root 2 because we're doing it under the radical. So inside the radical, we're going to multiply the numerator and denominator by 2. So we get negative the square root of 2 minus root 3 over 4. All right, and then that denominator, it's under a radical because it's really like the square root of 4. We could simplify it to the square root of 2 minus root 3 over just 2. All right, and that might look a little different from the cosine of 105 if we did it with the sum formula, but if we put them both as decimals, the cosine of 105 is the cosine of 105. It's the same thing. So sorry, you can't. Just let someone in and then it deleted that. Let's see if I can bring it back. There you go. All right, so I don't know if you can read that because of the watermark, but I'll rewrite it up here. So the final answer that we got was negative radical 2 minus root 3 over 2.
Wait, can you explain why the denominator went from 4 to 2?
Yeah, sure. So if you look at the formula, if I don't want to pull it up on my screen because then all this writing would disappear. But in the formula for the cosine, well, I'll rewrite it. So for the cosine of 2a formula, it's the square root of this entire fraction, like 1 plus cosine of a over 2. So that would be the same thing as like, if you think back to algebra 2, right? Like the square root of an entire fraction, like the square root of x over y is the same thing as the square root of x over the square root of y.
Oh, okay.
So like when we did this part here to get rid of the 2 to make this like more simple, that became the square root of 4. So we just did the square root of 4 and simplified the 2. Sound good? Cool. Let's do one more. All right, Mr. McDonald's gone. Anyone notice he just popped in here? It's stressful, man. I'm just sitting here doing my math in my quarantine bedroom, living with my parents, and he pops up, he starts messaging me. Like, come on, man. I'm doing the best I can. So if there's ever, if Mr. McDonald's gonna pop in and out of here. If you ever see him, just do your thing, just like natural. I feel like sometimes we do like really like fun and exciting things, and a teacher or like an administrator like will never walk into my class when we're doing something like, you know, like the group work or like one of those problem solving things. And then I'm doing like the most boring, straightforward, like non-creative lesson ever. And then they pop in. It's like, oh, give me a break. Like Dr. Gorman observed me like the last period before break for teachers convention. So like I wasn't gonna start anything new. I was like, all right, let's just like do some practice. It was a pretty simple lesson. Like I didn't want to do anything crazy. Yeah, it's the way the cookie crumbles sometimes. You just gotta be on point all the time. All right, so the sine of 22.5. Any suggestions here? Oh no, I have people's faces. Go away. Oh, I see a chat. 45 over 2. Beautiful. Let's do it. So, wow, someone else said something. 45 over 2. Very nice. I love the enthusiasm. So, yes, this is a time where you would use the half angle formula because it's 22.5. That's half of an angle that we could evaluate without a calculator. So, that formula is the sine of a over 2 is equal to plus or minus the square root of 1 minus the cosine of a over 2. So in this case, very good, like you guys told me in the chat, we're going to do the sine of 45 over 2. So using the formula, that becomes positive because 22.5 is in quadrant 1. The square root of 1 minus the cosine of 45, all over 2. All right, so now we're going to evaluate that. So we get positive the square root of 1 minus root 2 over 2, all over 2, right? So that 2 is under the denominator, right? And then any suggestions on how to make this more simple? Like, how can we get rid of that 2 there? Because we don't really want like a fraction inside of a fraction. It's not considered simplified. So we can multiply by a form of 1. Very good. Someone put it in the chat. All right, so we can multiply the numerator and denominator by 2. That doesn't change anything. It's still keeping the same value because it's a form of 1. So we get plus the square root of 2 minus root 2 over 4. And then that over 4 part, we can reduce that because the square root of 4 is 2. So we get positive the square root of 2 minus root 2. Oops, wrote that wrong. Oops, we're not going to be able to see this because of the watermark. So we'll write it over here. That's going to be the square root of 2 minus root 2 all over 2. And that's it. All right. Give you a second to write that. But I can't see your faces, so I'm not sure if you're done writing. And if I pull up your faces, then the writing will go away. All right, so that's the gist of it. So let me pull up one of these homework ones. Let's just do one more where we have to draw a picture, and then I'll let you guys go unless you have questions. So the same idea here, same formula, just we don't know what A is, so we have to draw a picture. So if it gives us the sine of A or the cosine of A, like doesn't specifically tell us what the angle is, but gives us enough, very good, gives us enough information to draw a picture, we'll draw a picture and then we can use that information. So the sine of A, where A is in quadrant 3, is going to look like this. And that's the reference angle. And the sine of A is negative 3 over 5. So the opposite leg is negative 3. The hypotenuse is 5. And then the adjacent leg is 4. So if I was doing number 5, all right, the cosine of a over 2, okay, I would use the formula, the square root of 1 plus the cosine of a over 2. So now we use the picture to evaluate this part. Now, we know that a is in quadrant 3 because that's given to us. So we can assume that a is in between 180 and 270. Now, you might be thinking, well, what if it's a coterminal angle? Then you could just find, like, let's say it's an angle like bigger than 360, then you could just find the coterminal angle and then do the same process and it'll work out the same way. So you don't have to worry about that. You can pretty much assume for this that all angles are in between 0 and 360. All right, so when we divide everything by 2, we get the half angle. So this angle here that we're taking the cosine of is in between 90 and 180, which is quadrant 2, which means that this is going to be negative because the cosine of any angle in quadrant 2 is negative. All right, same thing for secant. So now we're going to evaluate this. So I get the cosine of a over 2 is equal to negative the square root of 1 plus the cosine of a. So by looking at the picture, I see the cosine of a is 4 over 5. All right, all over 2. Now I kind of wrote my radical weird, so I'm just going to rewrite it like that because I didn't write it long enough here. All right. So now we could just simplify this a little bit. So we get 1 plus 4 over 5 is going to be 9 over 5. So negative radical 9 over 5 over radical 2. So then this could be simplified by, we can multiply the numerator and the denominator by radical 5 to get rid of that in the denominator here. So then it becomes negative radical 9 over radical 10. All right, I'm sorry, it's getting blocked by the watermark. All right, so we multiply by this form of 1 to get rid of that 5. So we get negative radical 9 over radical 10. And then we know that radical 9 is 3 because 9 is a perfect square. And then you could now multiply the numerator and the denominator by root 10, and we get our final answer, negative 3 root 10 over 10. That would be the cosine of a over 2. And we could also do the secant real quick because we know that that's the cosine of a over 2 is equal to negative 3 over radical 10. So if we take that one that's unsimplified, that has a radical in the denominator, and we flip it, that becomes radical 10 over negative 3. So it's just the reciprocal of our answer for number 7. All right, and then if you wanted to check this with a calculator, you can then just do like you could figure out what a is by doing the sine inverse of a. And then whatever angle you get, just make sure that it's in quadrant 3. So find the reference angle and by doing the sine inverse of 3 over 5, and then find it in quadrant 3, and then just plug it in, and you should get that same answer. So I'll show you how to check with the calculator real quick, and that's the last thing that I'll hold you here for. Anyone have any questions?
I have a question about the last problem you just did.
Sure.
How come you used positive 4/5? Like I know it was in the second quadrant, but
yeah, Dan, shouldn't have, because it's in quadrant 3. That's my bad. I should have used the negative.
Okay. Sorry.
No, thank you. That's my fault. Just rushing through it. So yeah, that should have been a negative. So that was a mistake. So let's check with the calculator, and then we'll come back to that because it's just a slight change. So it was so here's how you can check with the calculator. Do the sine inverse. So we're in degrees. So good catch, Shambi. Nice. Glad you caught that. So do the sine inverse of positive 3 over 5. All right. So we get the reference angle is 36.8699. Now this angle is in quadrant 3. So that means it's 216. So that's the sine of A, right? If we did the sine of A, we're going to get negative 3/5, and it's in quadrant 3. So now we do the cosine of A over 2, so this half of it, and we get that number. Now, let's redo it with the correct picture. So, and I showed you how to simplify it, so don't simplify it again. So this would be in quadrant 3, where the opposite leg is negative 3 and the adjacent leg is negative 4. Okay, so if we're doing the cosine of A over 2, all right, that's, we said it was negative radical 1 plus negative 4/5 over 2. So that would be negative radical 1/5 over 2, which would be negative radical 1 over 10. All right, so if we did negative radical 1/10, right, because it's plus cosine of theta, cosine theta was that, so that should come out to the same thing. So negative radical 1 over 10, so that's what it simplifies to, and then we get the same answer. All right, so here's how you do it with the calculator, how to check it, like even when you don't have the angle, and then that's how you do it by hand. All right, cool.
What would secant be if it's negative 1 over, negative radical 1 over 10?
So yeah, so secant of the same angle would be, you can just flip it to 10 over radical 10, and then that's going to simplify to just negative radical 10. So we just flip that. So it simplifies to radical 10. And then as a decimal, it's going to be that.
Thank you.
No problem. All right, good work. I'm going to end this recording.